All right, welcome to this platform. Of course, this is the mentor Hampeyo Climan. Today we shall be looking at dimensional analysis, and then we are going to go deep into this particular topic and eventually be able to solve as many problems as we can. Now, to start with, what exactly is dimensional analysis? So I'm going to give a definition for dimensional analysis quickly. So dimensional analysis, dimensional analysis is a method, in physics which is used to analyze, compare, and check the consistency of physical quantities. And check the consistency of physical quantities. By considering the dimensions of physical quantities of mass, length, and time. Now, this is very important. This is very important. By considering the dimensions of physical quantities of number one, mass, length, which is L, and of course time. Which is T. And of course, if you found the lesson interesting and helpful, don't forget to subscribe, hit the like button, and also share to others. And also don't forget to call the number you see on my screen. That is our WhatsApp number. Now, dimensional analysis is simply a method in physics which we use to analyze, to compare, and also to check the consistency of physical quantities by considering the dimensions of three physical quantities: the mass, the length, and the time. Let's go deep to see some examples of dimensions. Examples of dimensions. We're going to look at a number of them, then we see how they apply. Now, these are very important and you have to know them by heart. The first one that we're going to look at is a physical quantity we call length. What are the dimensions of length? The dimensions of length is simply capital letter L. We come to B. What are the dimensions of acceleration? Make sure we know this. The dimensions of acceleration represented by small letter A is simply, because we know that the units for acceleration is meters per second. Meters per second. What are the dimensions of mass? The dimensions of mass, before we even go there, let me put it this way. If we had mass as a physical quantity, what are its dimensions? The dimensions of mass is simply capital letter M. Okay? You are supposed to know the length, the mass, and time or period. How about the dimensions of time? Also known as period. So the dimensions of time, okay, are simply capital letter T for the period. Now we can find the dimensions of acceleration just from the units, because we know that the units of acceleration are simply meters per second. Then what is the meter? A meter represents the length. So the dimensions of length has already been stated. It is capital letter L. So you are going to, sorry, it's supposed to be meters per second squared. Okay. So you are going to put your L where there is M, and then S is the second. So it is second to the power 2. What are the dimensions of time? The dimensions of time is capital letter T. So you're going to put your capital letter T to the power 2. And this becomes the dimensions of acceleration. Okay? So those are the dimensions of acceleration. Okay? That's very important for you to be able to really understand. So the dimensions of acceleration is simply Lt to the power 2, right? We go on further. How about the velocity? How do you find the dimensions of velocity? Velocity represented by V. Remember, same as acceleration, we can generate its dimensions because we know that velocity is simply meters per second. Then the meter is simply a measurement of length. So we're going to put our L over the second is a measurement of the period or T. So we are going to put our capital letter T in the denominator. Okay? And that becomes the dimensions of velocity. How about the dimensions of distance or displacement? Okay? How do you go about writing its dimensions? Pause this video and try out to see the dimensions of distance or displacement. Well, the dimensions of distance or displacement is basically L because it is still the length. So this becomes L. Now, having understood these dimensions, these are very important, and most of the things will actually come from whatever we have listed on the board. Now, I want to give you this very important concept. Okay, so let's say important concept. So what is this important concept I'm about to give? This concept is called the MLT concept. Okay? M-L-T concept. Now, what is the MLT concept? M is basically standing for the mass. L is basically standing for the length. And then T is basically standing for the time period. Now, if you understand the MLT concept, then everything is going to become simple because you are supposed to put everything in MLT concept for you to be able to solve MCQ questions or multiple choice questions, as well as the questions that are going to be involving equations. I'll be able to show you. Okay? Now, let's try to put these particular physical quantities in MLT concept. So we have let me give this particular question. We say find the dimensions. Find the dimensions of the following. physical quantities. So, the first one we're going to look at is force. How do you find the dimensions of force? And how do you put those dimensions in MLT concept? Remember that force is actually equal to ma, the mass multiplied by the acceleration. So you'll be generating your dimensions from the formula of the given quantity. Use the formula of the given quantity to come up with your dimensions. Remember that force is equal to ma. Now, what are the dimensions of the mass? Dimensions of mass is simply capital letter M. Then what are the dimensions of acceleration? I already showed you that acceleration, the units were meters per second squared. So from this, you are able to generate its dimensions because you know that the meter is length, and then the s is the second representing the time. Because s has got power 2, you put a power 2 here, right? So for force, you are going to have, where there is mass, you put capital letter M, open bracket, then you say L over T to the power 2. So force is going to equal to, now how do you put it in MLT concept? So we shall be putting everything in MLT concept. In MLT concept, you have the mass, like there, like that. You are going to have the length. Now, because t is in the denominator, when it goes in a straight line in this particular form, it's going to have negative 2 to the top. Then this becomes the dimensions of force. Okay? That's how you write the dimensions of force. We got B. We are going to have work done. How do you find the dimensions of work done? Remember that work done is equal to force multiplied by the distance. Then we've already found the dimensions of force. The dimensions of force in MLT concept, it is simply M, L, T to the power negative 2. So even here, we are going to replace the same dimensions. Okay, like that, like that. What are the dimensions of distance or displacement? It is simply capital letter L. So you're going to put your capital letter L here. Now this L is multiplying this L, so you're going to have M, L to the power 2, then T to the power negative 2. So that is how you come up with the dimensions of work done. We proceed. We got to see pressure. How do you come up with the dimensions of pressure? Remember that pressure is simply force over area. What are the dimensions of force? You've already calculated because you know that force is simply having the dimensions in MLT as M to the power 1, L to the power 1, then T to the power negative 2. What are the dimensions of area? Area, the formula is L times B. This L is simply the length. The base is also a distance, so it's represented by length. So this is just the same as L times L, which is going to give you L to the power 2. So the dimensions of area are simply L to the power 2. So where there is force in MLT, you're going to put it like this. You put your dimensions of force over, then you put your L to the power 2. Notice that this L and this to the power 2 are going to cancel. Then in MLT concept, or let me just say you are going to remain with M, T, negative 2 over L. So how do you put that in MLT concept? In MLT concept, it's going to be M, L to the power negative 1, because the L is going on top, then T to the power negative 2. This becomes the dimensions of pressure. Okay? Quite very interesting and very simple. We got to D. D, we have the momentum. What is momentum? What is the formula of momentum? Momentum is simply mv. What are the dimensions of the mass? What are the dimensions of the velocity? So the dimensions of mass is simply capital letter M. What are the dimensions of velocity? The dimensions of velocity, because we said velocity is meters per second, the meter is represented by L, the S, which is the second, is represented by T. So the dimensions of velocity is simply L over T. So how do you then put it in the formula? So momentum, okay, momentum is going to be represented by, you are going to put your mass here, open bracket, then you have your L, then your T. So in MLT concept, this becomes M, L, then T to the power negative 1. That is how you write the dimensions of momentum in MLT concept. Quite very simple. We go to area. How do you find the dimensions of area? Because we know that area is simply L times B. But remember that the length is simply meters. The base is simply meters. So this is just the same as area is equal to L times L, which is just L to the power 3. And these are the dimensions of area. But how do you write this in MLT concept? So in MLT concept, it's going to be like this. Because you know that what you have is only L to the power 3, it implies you're going to put a 0 here, a 3 here, a 0 here, and this becomes the dimensions of area in MLT concept. Why am I putting M to the power 0? Because you know that any number raised to the power 0 is 1. 1 multiplied by L to the power 3, it will still be L to the power 3. It will be still one and the same thing. Let's go F. We have the volume. Volume is equal to L times B times H. If you notice, I'm coming up with a formula first, because inside the formula, there are physical quantities whose dimensions you know. So, what there is, this L is simply the meter, so represented by L. We know the dimensions of length, height, and distance. One and the same thing. Times L, times L. Then this is going to be L to the power 3. These are the dimensions, sorry. Okay, so here is supposed to be L to the power 2, not really to the power 3, sorry. Okay, so even there's a mistake. Very good. So this is going to be L to the power 3. So L to the power 2 is area. L to the power 3 is volume. So how do you write it in MLT concept? The same thing. It's going to be M to the power 0, L to the power 3, T to the power 0. And it gets in MLT concept. That's quite very simple and very interesting. Which other physical quantity can we also look at? Let's try to look at density. Density. Okay, so this one was, let me see, what was this? F. Oh, we're going to G. So we are looking at density. What is the formula for density? It is simply mass over volume. What are the dimensions of mass? The dimensions of mass is capital letter M. What about the volume? Remember that volume is simply L to the power 3. Where there is m, we are going to put capital letter M. Where there is v, we put L to the power 3. So density, its dimensions in MLT concept is going to be m L to the power negative 3, T to the power 0. Then this becomes the dimensions of density. How about surface tension? Quite very important. How do you write the dimensions of surface tension? I'll use the same concept. What is the formula for surface tension? It is simply the force over the length. What are the dimensions of force? The dimensions of force is simply m L T to the power negative 2. And then you're going to have the L in the denominator. This and that is going to cancel. Then you're going to have m T negative 2. So in MLT concept, this is just the same as m L to the power 0, T to the power negative 2. And then you have your dimensions. This is quite very interesting. Having noted this, we can try out some solutions. We can try out also to be able to apply our dimensional analysis in the study of physics. Now, we have a question, so we can say task. The first question is actually saying, prove using dimensional. So we prove using dimensional analysis the following given formulas. Sorry. So the first formula that we have is, so they want us to use dimensional analysis to prove that this formula is dimensionally correct or dimensionally incorrect. So that is the whole essence of dimensional analysis. It can help us to know whether a physical quantity holds or it does not hold. Your V is equal to V initial plus AT. How do we prove that this formula is dimensionally correct? Remember that in dimensional analysis, for you to be able to know that this formula is dimensionally correct, your left hand side and your right hand side, they should be equal. So, what are the dimensions of V? So we are going to say left hand side. So for the left hand side, we have this. What are the dimensions of velocity? So the dimensions of velocity is simply L over T. We go to the right hand side. The right hand side is the entire of this. So what are the dimensions of velocity initial? Velocity initial is going to be L over T plus what are the dimensions of acceleration? Acceleration is simply L over T power 2. Acceleration and gravitational field force have the same dimensions. Then the dimensions of time or period is simply T. So notice that this T and this T will cancel. Then on the left hand side, we are going to have L over T, then equal to, then this side we have L over T, and then because we have cancelled this T and this T, we are going to have L over T. Okay? So, notice what is happening. You'll notice that at the end of it all, you are going to have something which is going to look like this. L over T is equal to, when you add this and this, you are going to have something like 2L over T, right? Which is just the same as L over T. Okay, let me just wrap the equal sign not to confuse you. I want you to see how I'm going to conclude it. So I'm going to have it's supposed to be L over T on your left. So L over T is equal to what? So you're going to factor out the 2, and then you're going to put your L over T inside. Notice that what you have here is also what you have here, because a constant is not considered as a dimensional factor. Okay? So, because on the left-hand side we have L over T, on the right we have L over T, we say, in conclusion, this formula, sorry, I'm writing what I'm saying. So we said this formula is dimensionally correct, but physically incorrect. Okay? Why is it physically incorrect? Because of the 2. Okay? So you comment like that. This formula is dimensionally correct, but physically incorrect. Let's proceed to another one. The second one, they've given us period is equal to 2 pi, the root of L over G. What are the dimensions of L? What are the dimensions of G? What are the dimensions of T? But before we go any further, let me make mention. Whenever you see a constant is not a recognized dimensional factor. In other words, issues of things like 2 pi or pi or just any number or theta, these are not recognized under dimensional analysis. They are constants. Henceforth, we won't be able to recognize them. So, this is just the same as T is equal to the square root of L over G. What are the dimensions of T? The dimensions of period is simply capital letter T. What are the dimensions of the length? The dimensions of length is simply capital letter L. What are the dimensions of gravitational field force? By now we know what acceleration and its dimensions are. It is simply L over T to the power 2. So, this is just the same as T is equal to the square root of L over 1. Then because we're multiplying, this is going to be T to the power 2 over L. You cancel out these two. Then you're going to have T is equal to the square root of T to the power 2. Okay? Then this and that will cancel. So you're going to have T is equal to T. Notice that your right-hand side and your left-hand side are the same. So you would conclude by saying this formula is dimensionally correct. That is how you conclude dimensional analysis. Okay? Sorry. Okay? That is how how you conclude dimension analysis. It's very, very important. We get to the third formula. The third formula, which is going to be our C, we've been given KE is equal to half MV, then power 2. Now, how do you use dimension analysis to prove this? Remember that kinetic energy is measured in joules, and the units for joules is simply it's supposed to be kg meters to the power 2 per second to the power 2. So this is what we are going to have on our other end. So this is going to be meters per second to the power 2. So of course I'm going to put my meters, So I'm going to put my kg meters to the power 2 and then s to the power 2. Now let's try to really see how this is going to apply. So this is what we have on our right hand side. So on our left hand side. On the other end, this is not considered a dimensional factor. What are the dimensions of mass? The dimensions of mass is simply capital letter M. What are the dimensions of velocity? Velocity is simply L over T. Then because it's got a power 2. So this is going to be kg M power 2 S power 2. Then this is going to be M. Then this is going to be L to the power 2 over T to the power 2. Okay? So this is still kg is equal to, so this is just the same as M multiplying L to the power 2 over T to the power 2. Now, I want, because this is in MLT concept. This is just in MLT concept. But I can choose either to take it in units. If I take it in units, let me show you what I'm trying to say. Let me take it in units. This is the mass. The units is simply kg. This is the length. The units is simply meters per second. Meters. This is the period. The units are meters per. The units are second to the power 2. So have you seen that in units, it's just one and the same thing? What you have on your right hand side and your left are the same. You can use this as your proof. But if I wanted, from where it was at kg, then you have the meter to the power 2, then you have the second to the power 2 is equal to, you have your MLT there, right? I can take it into MLT concept because you know that this is simply the mass. This is simply L to the power 2. Where you see the meter, it's L to the power 2. Where you see the second, it is simply your period. And then this is going to be the same as what we have on our right. And everything holds. Okay? And then everything holds just like that. Okay? Basically, this is just how you solve questions on dimension analysis. Let's try to solve D. How do you use dimension analysis to prove that this formula is going to be dimensionally correct or consistent? So here the conclusion is this formula is dimensionally consistent. So we come to the next one where we have y is equal to, you open the bracket, then they're saying this is 2 meters, and then cosine, and then this is kx, and then they're saying where k is equal to 2 meter negative 1, right? Now, how do you use dimension analysis to solve this? Very simple, guys. Let me make mention that this formula is simply under simple harmonic motion, and it represents the displacement x. It's just one and the same thing. Okay, I've just removed y because it would actually be confusing to quite a lot of people, because most people actually think x is displacement or distance in physics. Now, what are the dimensions of distance? The dimensions of distance is simply capital letter L. Now, remember that under dimensional analysis, it's very important to really take note that your cosine does not matter, or it's a constant. Literally, we are going to remain with 2m. Now, because the 2 is not a recognized dimensional factor, we'll remain with the meter. What does the meter represent in dimension analysis? It is simply capital letter L. And then this becomes dimensionally correct. Okay, so this formula is dimensionally correct. Now, this is how you use dimensional analysis to be able to prove as many questions as you can. There is one interesting question that I would love us to do, which is going to ask you, or which is going to require you to use your MLT concept. Let me show you just how to use MLT concept to solve complex questions under dimensional analysis. We have this particular question. Let me name it E. So this question is simply saying the period. So the period T of a soap bubble, the period T of a soap bubble under simple harmonic motion is given by, then they say, okay, so this is T is equal to P to the power A. Okay, so this is multiplication, then P to the power B, and then S to the power C. Okay, where P is pressure. I want you to see the importance of what I am from giving you in this particular lesson, especially, okay, just at the beginning. So you have this is your density. Okay, so let me put it this way. Okay, so this density, and then they say, and S is surface tension. I want you to see how this question is coming. Find, then they say find the values. Find the values of A, B, and C. Okay? So these are serious complex questions that you are going to be solving. So let's do solution. Now, this particular question is actually very important. The same way I am going to solve it is the same concept you shall be using to solve the others. How do you solve about this question? Very simple, but a bit complex. The first thing you do, collect your formula. So your formula is the period is equal to, you have the pressure to the power A multiplied by the density to the power B multiplied by the surface tension to the power C. Let's come up with the dimensions of each of the properties that have been given. What are the dimensions of period? Already taught that the dimensions of period is capital letter T. What are the dimensions of pressure? The dimensions of pressure, because pressure is simply force over area, so we shall repeat, force over area. What are the dimensions of force? The dimensions of force in MLT is simply M L T to the power negative 2. Then because area is L to the power 2, so this and that will cancel. So what we are dealing with is simply M L to the power negative 1, T to the power negative 2. So for the force, its dimension is simply M L to the power negative 1, T to the power negative 2. Right. Basically, we can cancel every other thing because we now have our useful dimensions. Okay? We now go to the dimensions of surface tension. Surface tension is simply force over length. The dimensions of force already mentioned that it is M, L, then T to the power negative 2 over L. This and this will cancel. So basically, you are going to remain with M, T to the power negative 2. Okay? Like that. Okay? That's really very important for you to take note. What are the dimensions of density? Density is simply mass over volume. The dimensions of mass is simply capital letter M, and then volume is simply L to the power 3. And then this is going to become M, then L to the power negative 3. Now we have everything. Let me just summarize everything, all my tools, and put them here. So the dimensions of period is simply capital letter T. The dimensions of pressure is simply M, L, negative 1, T, negative 2. The dimensions of surface tension, so I have come up with all the needed dimensions. That is basically what I want you to be doing. Let's come and do density. The dimensions of density is simply ml to the power 3, negative 3. Now we can rub every other thing because you now know what you have. Now, remember I taught you MLT concept, and this is the other use of MLT concept. It helps you to solve complex questions under dimensional analysis. From there, while there is T, we now put everything in MLT concept. So, how do we put the period in MLT concept? Because we only have T, so it's going to be M0 T to the power 1. Okay, so it's MLT. Anyway, you already know, so L is supposed to have 0. So in MLT concept, the period is going to be replaced with M to the power 0, L to the power 0, T, because the T is already present, it's here, so it's going to be T to the power 1. Just put a 1, it's okay. Open bracket. We now put the dimensions of pressure. For pressure, in MLT concept, we already have it, it's here. So it's going to be M, L to the power negative 1, T to the power negative 2. Then you put to the power A, multiplied by density. Density is simply ML to the power negative 3. So on the other end, while you're replacing, just put what you have. Don't put to the power 0 or something. Just go on like that. Okay. How about surface tension? Surface tension is simply MT to the power negative 2 to the power C. Now, we need to generate equations which are going to help us solve these problems. So the first equation is going to start with M. So we're going to have M to the power 0 is going to equal to, now, we are going to multiply all the M's this side. So this M, and this M will multiply. Notice that when you multiply this M, it's going to be M to the power. So you're going to have the M, then maintain the base, add the powers. So this A is affecting this M here. So it's going to be M to the power A plus. This M is having B as a power. So plus B plus. This M is also having C as a power. So plus C. Okay. Then you cancel out the bases. You're going to have an equation. 0 is equal to A plus B plus C. This becomes your equation 1. We go to the second one. Let's use L. Okay, so this is going to be your first equation. Let me just underline it. We go to the second one. Let's use L to the power 0. We multiply all the L. So we have this L and this L. So this is going to be, you maintain the L. Now this A is multiplying this negative 1. So it's going to be negative A. Then this L, okay, has a power negative 3, which is here. So this B is multiplying that. So it's going to be plus, of which negative multiplied by positive is negative. So it's going to be minus 3B. Then from there, we can just cancel out the powers. And then we're going to have 0 is equal to minus A minus 3B. This becomes our second equation. Okay. Then we get for T. So T to the power 1 is equal to, we have this T here, which is whose power negative 2 is multiplying this A. So we're going to maintain the base. Then this is going to be 2A. You just do the same thing. And then it's going to be minus 2C. And then you cancel out the bases. You remain with the powers. The rest is simply algebra. This becomes your equation 3. Now, we need to solve these equations using substitution method. So the first thing we're going to do, we are going to get the simplest equation, which is this equation 2, because we know that equation 2 is 0 is equal to minus A minus 3B. So the B can come this side, the 3B can come this side. Or basically, let me just say, okay, it's just one and the same thing. So we're going to have minus A is equal to positive 3B, then over negative 1 over negative 1. Quite unnecessary, but anyway, I just needed to get the A on the other end. So it's one and the same thing. So this is going to be 3B. Okay. Then this 3B, I can now replace it in this particular equation. Okay, let me replace it in equation 1. We see if it's going to give us anything. So if I replace this equation here, I put it in equation 1. Let's see what we're going to have. So equation 1 was 0 is equal to A plus B plus C. Now, where there is A, we replace with minus 3B plus B plus C. Then we're going to have minus 3B plus B plus C. So 0 is going to equal to minus 2B plus C. Okay? Like that. So this is the equation that we have. Now remember that from here, we are going to make C the subject of the formula. So let's try to make C the subject. So if we make C the subject, this guy is going to come this on the far end. Then we're going to have 2B, right? Now, we have our 2B there. So C is simply 2B. What then can we do about it? Notice that you have this particular equation 3. Equation 3 was simply 1 is equal to minus 2A minus 2C. You already have your C. Okay? You already have your C and you already have your A. So A is basically here. Then C is basically here. So let's replace. So it's going to be minus. Where there is A, I'm going to replace this equation here. So where there is A, I'm going to replace minus 3B. Let me see why C. Where there is C, I'm going to replace with 2B. Then this is going to be 1 is equal to positive 6B minus 4B. So we're going to have 6B minus 4B is going to be 2B over 2 over 2. Then, of course, our B is going to equal to 1 over 2. Now, B is 1 over 2, so we can find the C. So C was equal to 2B. So C is going to equal to 2, open bracket, 1 over 2. C is going to equal to, you cancel out this and that, it's going to be 1. Okay? Then let's find A. Where is A? Our A is here. So A is going to equal to minus 3B. A is going to equal to minus, where there is B, you replace with 1 over 2. So your A is going to equal to, A is going to equal to minus 3 over 2. And basically, this is how you solve this particular question, by simply using the MLT concept. If you found this lesson interesting and helpful, consider subscribing and also hitting the like button, and also don't forget to share. If you would want to register for personal tuitions, inbox plus 26077 66 40 46. Box me on WhatsApp and the mentor will be able to respond to you. Thank you so much.